Hi guys, and welcome back to my channel. In today's video we are going to see ionic and covalent compounds versus covalent compounds, right? So if you are new to my channel, please don't forget to subscribe and hit the like button for more videos, right? Now we're going to talk some basics. That means if you take the ionic compounds, right, it's made up of metal and non-metal, whereas covalent compounds are made up of non-metals. So usually ionic compounds are found in the solid state, right? And the covalent compounds are molecules, commonly, okay, molecules. So the common example for the ionic compound is sodium chloride, that is NaCl. You would have known this, heard this very well. NaCl, that is a common salt. We can take some common examples of some covalent molecules like water, right? Then ammonia, and we can say many more, right? What is the basic differentiation between the ionic compound and the covalent compound? So we have to consider the melting points, melting and boiling points. So in ionic compounds, the melting and boiling points are very high. In covalent compounds, it's low, because in the ionic compounds the ions are formed, positive and negative ions. If we take sodium chloride, there is Na plus and Cl minus. So these ions, there is a great strong attractive force between them, so we need to give more energy to break the bonds. The melting and boiling points are very high. But in covalent bonds, there is no ions formed like that, only by sharing of the electrons. So the forces are weak forces of attraction. Here the attraction forces are very high, strong forces of attraction. So then we also need to consider the second thing, that is the solubility in water. So ionic compounds forms ions, so they are easily soluble in water, and covalent compounds are not soluble in water like ionic compounds. Then the third thing is conducting electricity, right? So there are ions formed. So in the melted state, or by dissolving in water, we can form the ions, so they can pass on a current. Here not conductible, right? They are not able to conduct electricity. So now we talked about the common things, but there are some exceptional giant covalent structures. So the famous one you already would have heard, the allotropes of carbon. So what is an allotrope? Allotrope means an element existing in two forms. So we have carbon in two forms. One is diamond and the other one is graphite. So these diamond and graphite are called some giant structures of covalent bonds. So you need to know diamond is one of the strongest element found. strongest element found in the earth. It's very hard and strong. So whereas graphite is weak. So if you consider the carbon atom, right, I already told you from the basics, that is the atomic number of carbon is 6, so the electron configuration is 2, 4. So there is 4 electrons in the outermost shell, so it can bind with 4 other, right? So in graphite it's binding with all the 4 bonds are binded with another carbon, and it goes on like that, forming a giant lattice. But in graphite, only 3 of the carbon gets paired with the other, and there is an extra lone electron. So when we compare both of them, this is soft and this is hard, then it has, both of them has a giant structure, covalent structure, and this cannot conduct, not conducting electricity, cannot conduct electricity, but this will conduct electricity because there is a mobile electron. When there is electron able to move along, it will conduct electricity, right? So this is found in the pencils, right? Pencil point is made up of carbon, graphite, yeah. And this in some jewelries, right? You know what is diamond? Very expensive and very hard. So both of them have a giant covalent structure and they have high melting boiling points. Alright, then we need to talk about one more element that is coming under the giant covalent structure, is silicon dioxide, right? This is also called as silica, and this is found in, it is a mineral found in the sand. So this silicon dioxide is also a giant covalent structure and it has a strong covalent bonds are formed in this. So that's all. Let's wind up the session today.